Hi guys, this geometry review video will be going over trig. Feel free to use the timestamps to skip around. Okay, let's start off with trig ratios. We can use trig ratios to find the unknown side lengths or angles in right triangles. So if we're given triangle ABC, we can say that this is theta, and the side length that is opposite from theta is always going to be the opposite side. The side length adjacent to theta is always going to be known as the adjacent side. And the side opposite from the right angle is going to be known as the hypotenuse. We can memorize trig ratios by using SOHCAHTOA, where sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Okay, moving on to reciprocal trig functions, cosecant is equal to 1 over sine, secant is equal to 1 over cosine, and cotangent is equal to 1 over tangent. Okay, here are just a few practice problems. For A, we're given angle 35 and then the opposite side x and the hypotenuse 10. So you can do sine of 35 is equal to x over 10. And just do 10 sine 35 is equal to x. Plug that into your calculator, you get 5.74 is the approximate value of x. For B, we have to find the value of y. We're given the angle 23 and also the opposite side and the hypotenuse side. So you can do sine 23 is equal to opposite, which is 15 over y. And we can do y is equal to 15 over sine of 23. And plugging that into your calculator, you get around 38.4. For C, we have to find theta. Based on theta, we're given the opposite side and the adjacent side. So we can do tangent of theta is equal to the opposite, which is 7 over 6. Okay, then we can use the arctan, which is this, to find theta. So just plug that into your calculator and you get around 49.4 degrees. Okay, moving on to cofunctions. When a function of acute angle is equal to the complement of another function, the two functions are called cofunctions. So for example, the sine of one angle is equal to the cosine of its complementary angle. So for sine of 37, we can just do 90 minus 37 to find the complementary angle, and we get 53. For cosine x, to find the complementary, we just do 90 minus x. For sine x plus 3, we can do 90 minus x plus 3, which gives us 87 minus x. Okay, so this question right here asks us to find x. The sine of 3x plus 27 is equal to cosine 2x plus 13. So we know that these two are complementary angles, right? So 3x plus 27 plus 2x plus 13 is going to have to equal 90 degrees. So now let's just solve for x. 3x plus 2x is equal to 5x plus 27 plus 13, which is equal to 40. And then we can do 90 minus 40, which is 50. And then 50 divided by 5, which is equal to 10. So x is equal to 10. So solving the right triangle basically just means finding all the angles and all the side lengths of a right triangle. We're given 42 degrees, C is 42 degrees, and then the hypotenuse is 13. So you can use that to find x, the opposite side. So you can do sine of 42 is equal to opposite, which is x, over the hypotenuse, which is 13. So 13 sine 42 is equal to x. Plugging that into your calculator, x comes out to be around 8.7. So you know that x is around 8.7. And then to find the angle measure A, we can do 180 minus 42 plus 90, which is equal to 48 degrees, and that this is 48 degrees. And using that, we can find side BC. So the sine of 48 is equal to opposite over hypotenuse. So opposite, which is side BC, over the hypotenuse, which is 13. So 13 sine 48 is equal to BC. And plugging that into your calculator, you get around 9.66. Finding the functions of angles greater than 90 degrees. So right here we have the example sine of 715. First, we have to find what quadrant this angle is in. So if we have this axis right here, and we know that this is 360, this is 90, 180, 270. And if it goes around one time, it's 360, right? If it goes around two times, it's 360 times 2, which is equal to 720. So angle 715 would be somewhere around here in the fourth quadrant. Okay, to find the sine of that function, we can use all students take calculus. All the functions in the first quadrant are going to be positive. Only the sine in the second quadrant is going to be positive. Only tangent in the third quadrant is going to be positive, and only cosine in the fourth quadrant is going to be positive. Sine of 715 is in the fourth quadrant, so that means that it'll be negative. Now we have to determine the reference angle. We can do 715 minus 360, which is equal to 355. And 355 is pretty close to 360, so we can just do 360 minus 355 to give us 5. So the reference angle is going to be 5. We know that since it's in the fourth quadrant and it's sine, it's going to be negative. So we can do negative sine 5 is going to be equal to around negative 0.0872. Okay, here are just a few examples. The cosine of 435, we can imagine it to be around here because after 360, if you add 90, this is going to be 450. So 435 would make sense to be here in the first quadrant. And then to find the reference angle, we can just do 435 minus 360, which is equal to 75. Since this is cosine in the first quadrant, we know that it's going to be positive. So we can just do cosine 75 is going to be equal to around 0.26. Okay, for the tangent of 780, we can imagine the angle to be in the first quadrant as well. So we can do 780 minus 360 is equal to 420. 420 minus 360 again, which we get 60. 60 is our reference angle, and since it's tangent in the first quadrant, we know that it's positive. So tangent of 60 is just equal to radical 3. To find the sine of negative 90, we know that it's somewhere in the third quadrant. So according to all students take calculus, it's going to be a negative function. To find the reference angle, we can just do 190 minus negative 180, and we get 10. So negative sine of 10 is approximately negative 0.17. To find the tangent of 187 degrees and 30 minutes, we know that in 1 degree there is 60 minutes. Right? So we can just do 30 over 60, which is equal to 0.5. So 187 plus 0.5 is equal to 187.5. Now all we need to do is just to find the tangent of 187.5. This angle is somewhere in the third quadrant, so we know that's going to be positive. And to find the reference angle, we can just do 187.5 minus 180, and we get 7.5. So the tangent of 7.5 is approximately 0.13. Okay, so moving on to special right triangles, we have the 30, 60, 90 triangle and the 45, 45, 90 triangle. So if you find a triangle with these special right triangle angles, you can use them to find the side lengths and the angles because the side lengths are in a special ratio. So the side across 30 degrees is always going to be 1. The side across 60 is always going to be radical 2. And the side across 90 is always going to be 2. And then for a 45, 45, 90 angle, since we know that these sides are congruent to each other, they're always just going to be the same. So you only have to memorize that across the 45 degree angle, the side length is going to be 1. And then across the 90 degree angle, the side length is going to be radical 2. So to remember the trig functions that are associated with the special right triangles, we can just do 30s. And we can do 1, 2, 3, 3, 2, 1, and 3, 1, 3. And we put them all over 2. Except for this one is over 3. And then we put a radical on everything that's not a 1. So here's just one way to memorize it. But you can always just memorize like the side lengths and the angles that are associated with it. So you can memorize the 1, the 2, and then the radical 3, and then the radical 2 on the hypotenuse here, and then the 1s for the side lengths. Okay, here are just a few practice problems. Number 1 says find the side length of AB. We're going to label AB as x. Okay, so we can do the cosine of 30, which is equal to adjacent over the hypotenuse. We can do 6 radical 3 over x, and we know that cosine of 30 is also equal to radical 3 over 2. So we can do radical 3 over 2 is equal to 6 radical 3 x. So to get from radical 3 to 6 radical 3, we just do times 6. So 2 times 6 is equal to x. X is going to be equal to 12. And number 2 says, what is the perimeter of an equilateral triangle whose height is 2 radical 3? So if we have an equilateral triangle right here, we know that all the angles are going to be 60 degrees. And if the height right here is 2 radical 3, just split up this triangle into a right triangle, right? So this is 90, this is 30, this is 60, and this is 2 radical 3. We can do the sine of 60 is equal to the opposite over the hypotenuse. So 2 radical 3 over x. X is going to be here because we need to find one of the side lengths to find the whole perimeter. So we know that sine of 60 is also going to be equal to 3 radical 2. Radical 3 over 2. So radical 3 over 2 is equal to 2 radical 3 over x. So to get from there to there, we can do times 2. So x is equal to 2 times 2. X is equal to 4. But we're trying to find the perimeter, right? So we have to do 4 times 3, which is equal to 12. So the perimeter is 12. Okay, moving on to Pythagorean triples. We know that the Pythagorean theorem is a squared plus b squared, which is equal to c squared. So if we have a triangle right here, let's call it ABC. And this is C, this is B, and this is A. Okay, so one Pythagorean triple is the 3, 4, 5 triangle. So what we can use this for is, let's say we're only given that one side is 3 and then one side is 5. And we have to find the other side length. We immediately know that it's going to be 4 because it's a Pythagorean triple. The multiples of the 3, 4, 5 triangle are also Pythagorean triples. Times 2, we get 6, 8, 10.
Times 3, we get 9, 12, 15. Times 4, we can get 12, 16, 20. Times 5, we can get 15, 20, and then 25. And times 6, we get 18, 24, 30.
So you just go on, but these are the ones that you can remember. So angles of elevation and depression. The angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. So this is going to be the angle of elevation. And the angle of depression is formed by a horizontal line and an observer's line of sight to an object below the horizontal line. So this is the angle of depression. These two angles are alternate interior angles, which means that they are congruent to each other. So here are just a few practice problems. A man is standing 50 feet away from the base of a tall building. The angle of elevation from his eyes to the top of the building is 35 degrees. How tall is the building, assuming the man's eyes are 3 feet above the ground? So let's just draw it out right here. If the man is 50 feet away from a tall building, and from his eyes to the top of the building, the angle of elevation that is formed is 35 degrees. And we know that his eyes are 3 feet above the ground. We're going to try to find x, and then we're going to add it to 3 feet to find y. So to find x, we're given the 35 degrees and the adjacent side 50 and the opposite side x. So you can just do the tangent of 35 is equal to x over 50. So 50 tangent 35 is equal to x. X is around 35.01. So to find y, we can just do 35.01 plus 3, which is 38.01. So the building is around 38.01 feet. Stacy is skiing on a mountain with an altitude of 1,150 feet. The angle of depression is 35 degrees. Find the distance Stacy skis down the mountain to the nearest foot. So if she's on a mountain and the altitude is 1,150 feet, and let's say she's right here, right? The angle of depression is 35 degrees, and we want to find the distance that she skates down, so x. First, we can find this angle right here. So we can do 90 degrees minus 35, which is equal to 55 degrees. And now we can look at this triangle right here, right? We can do the cosine of 55 degrees is equal to 1150 over x. X is equal to 1150 over the cosine of 55. So plugging that into the calculator, x comes out to be around 2004.96 feet. Okay, so moving on to the area of triangle using trig. When you are given two sides and the angle between the sides, you can use these formulas to solve for the area of any triangle, not just a right triangle. So basically, if you are given triangle ABC, right? And then you know that this side is A, this side is B, and this side is C. Okay, let's say you're only given B, C, and A right here. You can use one of these equations to find out the area. These equations are basically the same. This right here is just the side lengths, the two side lengths you're given, and then this is just the angle that you're also given. So let's say you're given A, C, and then B. You're not going to be able to use this equation because you need two side lengths and then the angle between them. Here are just a few practice problems. Find to the nearest tenth the area of triangle ABC if A equals 4 centimeters, B equals 12 centimeters, and measure of angle C is 20 degrees. So let's say we have ABC right here. Side A is 4, side B is 12, and then measure of angle C is 20. So we can just do K is equal to 1/2 the side lengths, 12 times 4, and then the sine of 20. Okay, so K is equal to 1/2 times 48 times sine 20. K is equal to 24 sine 20. Okay, and if you plug that into the calculator, you get around 21.91 centimeters squared. Okay, let's move on to the law of sines. The law of sines states that in any triangle, the ratios of the length of a side to the sine of its opposite angle are constant. This is used to find any missing angles or sides in a triangle when two other angles and an angle are given, or two other angles and a side is given. So when two angles and one side are given in this orientation, or two sides and one angle are given, you can use the law of sines. Okay, here are just a few practice problems. Triangle XYZ, where x is equal to 12, y is equal to 40, z is 60 degrees, and then we're trying to find the length of z. So we can do z over the sine of z is equal to x over the sine of x. So we know that the sine of z is 60 degrees, x is 12, and then to find the sine of x, we can just do 180 minus 40 plus 60, which is equal to 80 degrees. Okay, now we can just cross multiply and solve for z. Okay, so the answer comes out to be around 3.68. Okay, in triangle ABC, A is 8, angle B is 45, and angle C is 75. Find the length of side C. So C over sine C is equal to, say, A over sine A. Sine C is sine 75, A is 8, and then we can do 180 minus 75 plus 45, which is equal to 60 degrees, so sine 60. Just cross multiply and solve for C. Okay, C comes out to be around 10.18. Law of sines, the ambiguous case. This means that there can only be 0, 1, or 2 distinct triangles that can be formed. So the side-side angle condition. So let's say we're given a triangle right here, right? And we're only given the side length right here is 5, 2, and then this angle is like 20. We're not given this angle, so that means that this side length right here, the 2, it could be right here, or it could be right here. Since we're not given what angle it is, we don't know how many triangles it can form, because it could be forming this triangle right here or the larger triangle. Okay, so to find the number of distinct triangles two sides and an angle can form, we can find the height right here, sine of 20 is equal to the opposite, which is the x that we're trying to look for, and then 5. So 5 sine 20 is equal to around 4.56. So since 2 is less than that, that means that it'll never reach the bottom here. You know what I mean? So like, since this is, let's say 4.56, and then this is 5, and this is 20 degrees. Since 2 is too short, it'll never be able to form a triangle. So that means that when you're given 5 as a side length, 2 as a side length, and then a 20-degree angle, it cannot form any triangles. Okay.
So a designer commissions a contractor to create a triangle window. The designer describes the window as triangle XYZ, where the measure of angle X is 40 degrees, and side XY is 14 inches, and side YZ is 18 inches. How many distinct triangles can the contractor construct using these dimensions?
Okay, so we can use the angle and the side that are adjacent to each other, and we can just find the height by using sine. So the sine of 40 is equal to x over 14. So 14 sine 40 is equal to x. X comes out to be around 10.43. And looking at this angle right here, it is greater than 10.43. This means that only one distinct triangle can be made. This is because, let's say, this was 14, right? And this was 40 degrees. And then the height right here is 10.43. Since 18 is way longer than 10.43, there's no way that it can go straight like this or into the triangle like this. So it can only go one way, which is outwards, so 18, which means that there is only one distinct triangle that can be formed. So the law of cosines can be used to find missing sides and angles when two sides and the included angle are given, or when all three sides are given and you want to find the angles. So here are just the following equations that you can use. They're all just the same equation. You can remember it by knowing that if you're doing a squared here, then angle A has to be in the cosine function, and then the two side lengths here are going to be here as well. So here are just a few practice problems. In triangle XYZ, Z is 10, X is 12, and angle Y is 43. Find the side length of side Y. So we can just do the side length with fighting, which is Y squared is equal to 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of, we can just solve for this to get Y right here. And then for triangle ABC, kind of the same thing. C is 8, B is 6, and the angle A is 60. And if we're trying to find angle A, we can just put angle A here and then do the given side lengths, 6 squared plus 8 squared minus 2 times the side lengths, 6 times 8 times the cosine of angle A, which is 60. And we can just solve that to find A.